You push your TypeScript Express app to production. The type checker gave 0 errors. Yet, within hours, your logs fill with type error, cannot read properties of undefined reading title. The culprit? req.body, you trusted the type annotations. But they vanished at runtime, leaving Express's middleware optional body parsing to fail silently. This is the hidden tax of mixing TypeScript and Express, a tax you pay in duplicate validation, frantic debugging, and shattered trust in types. Express is the de facto standard server framework for Node.js. When you first adopt TypeScript with Express, it feels like a safety net. You define precise interfaces for request bodies and write route handlers dependent on those types. The compiler flags any mismatch, a missing field, a typo, a wrong type assignment. TypeScript adds static typing with optional type annotations, enabling powerful tooling and catching bugs early. It's a key reason large-scale applications adopt the language. But here's the critical detail: the TypeScript compiler transpiles your code to JavaScript, removing every type annotation. The final Node.js process has no knowledge of your DTOs. Express, famously minimal, doesn't include body parsing by default. It depends on middleware like express.json. Your type annotations are a compile time promise that the runtime never keeps. Every time you write req.body as user, you place a bet that the JavaScript environment will honor a contract it doesn't know exists. This gap sets the stage for the cost we're about to unpack. When Express receives a post, it passes the request through a middleware stack. The critical step for body data is express.json, that middleware parses the incoming JSON and assigns the result to req.body. If you forget to call appuse, express.json, or if another middleware intercepts before it, req.body stays undefined when your handler fires. TypeScript types offer no protection here. They are erased when TypeScript compiles to JavaScript, meaning the runtime knows nothing about your user interface. Even when express.json runs flawlessly, the actual payload can be any valid JSON, missing fields, extra properties, mismatched types. TypeScript's compile time checks never see that data. The result, an app that compiles cleanly but crashes on a BAT request with type error, cannot read property of undefined. No amount of careful interface design prevents this, because the runtime doesn't enforce your contract. This is the core impedance mismatch. Once you realize that TypeScript types vanish, the natural response is to add manual runtime validation. You write a function that checks if req.body.name is a string, if email matches a regex, redefining your schema a second time. This duplication is the hidden tax. You now have two sources of truth: the TypeScript interface and the validation logic. They easily drift apart. A field renamed in the interface doesn't automatically update the runtime check. A new required field added to the DTO might be forgotten until a bug surfaces. Consider a typical app. A developer adds a required role field but only updates the TypeScript interface. The handler destructures req.body.role and uses it. TypeScript stays silent. In production, a request missing role passes through, and the code crashes. The validation function was never updated. This incident cost hours of debugging and a rollback. That's the duplicate validation tax. You pay with time and reliability for the gap between compile time types and runtime reality. The solution to the duplication tax is to make runtime validation the single source of truth for your data shapes. That's where XOD comes in. XOD allows you to define a schema, a precise description of the structure and constraints, using a fluent API. You write something like const create user schema equals z.object, name, z.string, .min, 1, email, z.string, .email. Then, using XOD's infer, you get the TypeScript type automatically, type create user equals z.infer typeof create user schema. This type is always in sync because it's derived from the same definition. In your route, you call create user schema.parse, req.body. If the body doesn't match, XOD throws an error you can convert to a 400 response. If it matches, the returned object is typed as create user, and TypeScript knows its shape. No duplication, no drift, and your production app stops crashing on bad input. This pattern pays back the tax immediately. Zod gives you a validated object at the boundary. But what stops a future developer from passing a raw req.body deeper into the service layer, bypassing validation? TypeScript's assertion functions provide a compile time guard. You can write a function like assert valid user, body, unknown asserts body is user. After that call, TypeScript narrows the type so the rest of the code knows it's safe. Similarly, branded types let you distinguish a raw string from a validated email. You define a type email equals string and __ brand email, and only the validation function can create it. Then your business logic only accepts email, preventing accidental misuse. These techniques complete the loophole. They enforce at the type level that only validated data reaches critical code. Without them, even with Zod, you could mistakenly call a function that expects validated data with raw input. With them, the compiler itself becomes a contract enforcer for your validation pipeline. This isn't just type gymnastics, it's practical defense against very real production bugs. When you add up the hours spent handwriting validation, testing it, debugging mismatches, and recovering from production crashes, the tax is substantial. Yet many teams accept it as the cost of using Express with TypeScript. The alternative, adopting Zod, assertion functions, and branded types, requires an initial investment. But that investment immediately eliminates duplicate validation code, keeps your types perfectly in sync, and hardens your app against malformed input. The real cost of the mismatch isn't the tools, it's the time you lose to bugs that TypeScript promised to prevent but couldn't. By shifting your source of truth to the runtime, you reclaim that time and restore trust in your type system. The choice is not about Express versus other frameworks, it's about acknowledging the gap and bridging it with proven patterns. The net effect: fewer 3 a.m. calls, more predictable releases, and a codebase where types are trustworthy. So next time you type req.body as